Well, 24 hours flies by. Actually, 48 hours at this point. The conference is coming towards a conclusion here. We've got about, T-minus 3 hours till the Exhibit 4 closes. I hope that each of you has found this useful and that you found it productive and worthwhile to your time, both those who are here as guests and those who are here as vendors and sponsors. I'm super excited about this last panel, and we're going to just jump right into it because I think we've got a full hour of content. So as we go through here, we've got 4 panelists here at the table. We've got a 5th that's going to join us remotely. Some faces you see are familiar that you saw this morning if you were here this morning. I'm going to go ahead and start off with one of our newest faces who is not here. Josh Brewer is the executive director for the Manhattan Area Habitat for Humanity, and that's Manhattan, Kansas. That's my hometown. And Josh and I have worked together for a couple of years now. I've served on the board. It's working on my 3rd year being on the board, and I'm currently the chair. Let me have Josh introduce himself and tell a little bit about Manhattan Area Habitat for Humanity.
My name is Josh Brewer. I am the executive director of the Manhattan Area Habitat for Humanity. We are an independent Habitat for Humanity affiliate that services 2 rural counties in northeastern Kansas. And our operations span construction repair, new construction, housing rehabilitation, and mortgage underwriting and mortgage servicing, so that we can create opportunities for home ownership for low income and workforce income category homebuyers.
All right, how many of you were not here this morning, just by show of hands? Okay, we got a few, so true. Dave, if you can introduce yourself again.
Okay, I think most of you have already heard this, but Dave Stevenson, I'm from Insulspan. We're a structural insulated panel manufacturing company. We have 2 manufacturing facilities, one in Michigan and another in Vancouver, British Columbia, just up the I-5 from here, which is where I'm from. I've been in the structural insulated panel industry for about almost 25 years now, and I am the sales rep for our Western division. But with my background in construction, I am also a site advisor for our company. And so I have just about as many years of experience with on-site SIP application installations.
All right, Jason.
Hi, Jason Carter with Bantam Global. We're a global housing solution that is entered the United States 4 months ago. We started out in a SIP panel solution. In the United States, we will be building volumetric 6-sided boxes. We've built about 3 million square feet in South America. Excited to be here. We are very focused on low carbon housing solutions.
And some of our new faces, we'll start off with Michael. Michael, tell us about yourself and who you're with.
I'm Michael Gibson. I'm an associate professor at Kansas State University and also a licensed architect. At Kansas State, I teach a studio called the Net Positive Studio, where master's students work on projects that they design, affordable net zero homes that they design and prefabricate. I do have a small residential practice that's kind of inching over into the prefab direction as well, but my research background is in building modeling and envelope design. So I didn't start with housing, but I'm from the Rust Belt. My family, a few generations back, was into fabrication, and so I developed a passion for the shop. So I kind of have my feet in 2 worlds.
Excellent. And Ted.
Hi, I'm Ted Clifton, designer and builder of net zero energy homes. We've been doing net zero homes in the Seattle area for about 12 years now, and building for just a little over 30. Got into doing SIPs about 20 years ago, and then slowly moved that into doing all electric, all net zero building.
So Ted is like this veteran in this space. I want to start off kind of our story today looking at what happened in Manhattan and what was put together, and I'm going to have Josh kind of tell it in his own words, but it was what we call the Workforce Solar Housing Partnership. And you're going to see a lot of logos here that a lot of partnerships are brought together. And why I think this is important for this audience is this is a group that in 2020 had not done building in this way and was able to accomplish it, which I think is very relevant for those of you. Most of you from this morning's session indicated you haven't really explored doing this before. So I'm hoping that this can be a starter of how can you just jump into this when perhaps you don't have any experience in it at all. So Josh, tell us about your story.
So our Habitat for Humanity affiliate historically has stick-framed, site-built houses, and has done so with the objective of delivering a product which is the most affordable housing product for minimum safety standards. And in the fall of 2020, following COVID disruptions to the supply chain, to the labor force, and to our investment stream through donations, we realized that we needed to go back to the drawing board and reimagine how we were delivering our housing type in our community. So we initially reached out to Kansas State University College of Architecture, Planning, and Design to help us rethink workforce housing. And what came out of that conversation was a fundamental shift in the process of delivering that housing type. And this is something that initially was a little difficult to wrap our head around. But with the capacity of the team at Kansas State University, we felt comfortable really jumping in and bringing along a partner at a local technical college, Manhattan area technical college, and an Army transition program called the Home Builders Institute for transitioning soldiers who are interested in the construction trades. And what this collaboration, which we've called the Workforce Solar Housing Partnership, imagined was a prefabrication approach that involved panelization prior to bringing panels to the construction site for assembly on site. And initially, we looked at some options for sandwich SIPs, but felt like for local building codes and inspectors, and for the acceptance from the local building community, we would need to incorporate studs into our structure. So we found a panel manufacturer in Idaho named Raycor that manufactured those stud panels. So a little different than a traditional SIP panel. And we brought those to the site at AP Design at Kansas State University. And then that team fabricated the units to be assembled on site from the panels. So the process had shifted. And then the other piece that the AP Design team, along with another nonprofit in the community called the Flint Hills Renewable Efficiency and Renewable Energy and Efficiency Cooperative, brought to the table was a commitment to developing net zero, or what they called net positive solutions. And so what we looked at along with Michael Gibson's studio team is how we could design the structure to have better thermal performance and better air tightness, so that we could create affordability by downsizing the mechanicals and by reducing the homeowner's cost of operating the home. Those cost savings allowed us also to install a solar photovoltaic array on the structure, which further reduces the cost of operations for the structure. Now, Kansas net metering requirements are not advantageous for producing energy. And so we, because we had energy modeling on the site, we were able to right size that array to maximize the the value for the homeowner, who ultimately takes out a mortgage that we originate and finance on the home. And so the bringing on the AP design team allowed us to put something to pilot a process that's not seen in our market currently, a prefabrication and modularized a panelized process that we have not seen locally, and which historically, when brought up, the building community did not feel would be appropriate to our community, or in many cases even possible in the community. And so this has allowed us to bring local architects and local builders to our build site after construction, and to involve the local subcontracting community, electricians who had some pretty serious concerns about how they could work in a structure that had panels, and HVAC professionals who had some questions about the performance of heat pump technology and the sizing of the heat pumps in a structure like this, all the way back to the concrete professionals who had not seen our slab detail, a high performance, a frost free, shallow slab type in residential construction. And so by being able to pilot this sort of innovative housing product in our local market, we've begun the process, hopefully, of normalizing performance construction in the low to moderate income affordability space.
Yeah, a little bit long, but I think good foundation to start with. So thoughts, reactions so far from those of you who haven't heard this story before, and then we'll have kind of Michael add his 2 cents, having been involved in it.
I mean, I agree with him in that, what we've found is our key in marketing is letting people know how much they're saving in utility bills by taking that extra step to make a super insulated and efficient structure. And so far, we found the payback for what we're doing all electric net zero energy houses. The payback's about 12 to 18 years for each individual technology. And if you're on a 30-year mortgage, that means your bills are less every month. So it's actually cheaper to get to that net zero goal than it is to build the code minimum. So like once people understand that, then you're like, okay, well then what's the cheapest way to get to net zero? It becomes your main goal.
That's a good selling point. Other thoughts?
No, I would agree. I think that, we're here mainly talking about, prefabricated systems. There's different types of panels which they've used, but the prefabricated panels are really only one part of an entire whole house solution, with mechanical systems and everything else that's incorporated. So it's not one thing or the other. It's more and more all of these different technologies combined for the.
Well, and once net zero gets to be the goal, you start to look at what kind of wall and roof details you need to get there. And if you look at like the architect's ideal wall and some of these assemblies, you look at and you think, wow, that is really complicated. And some of them are incredibly complicated with like 6 different layers of parts. And with a SIPS wall detail or a SIPS roof detail, it's like the simplest thing you've ever seen. I mean, it's super easy to assemble. It's just, you just put that on, and that's all your framing, your insulation, your air sealing is all kind of done all in one really fast setup.
So Michael, you want to tell us a bit about what we're seeing here?
Sure. So, and I think something to emphasize with what Josh said was that we're working with learners. So they're working learners, and I'm excited to be on the educational side of this because I think it's something it's just going to keep gaining traction. So this is the way that we produce our panels in the shop, and these are actually Masters of Architecture students. They're not they're not construction students, but they design the house. They develop a fabrication drawing set in addition to their CD set, and they put it together, and it goes out on the site. And so far everything fits together. It's kind of a magical thing to see those pieces come together. People are really surprised if they don't know much about prefab, how quickly the shell goes up. And actually, one of the things that happened in Ogden, Kansas, when we were building the build 2 years ago was a bunch of school kids walked by the site in the morning.
This is the house you're talking about.
Yeah, they walked by the site in the morning, and then at the end of the day, the walls were up, and we were starting to work on the ridge beam and stuff. And they're like, "Whoa! Like, where'd this house come from?" So these are small houses. I think some of the design points, the value of design is we right size the house. So these are our houses are typically under 1,200 square feet. That allows you to make a really robust envelope, invest in systems and finishes, and make it a space that feels big, even if the floor area is not very large. So how many people in here are architects? How many people work with architects on a regular basis? Okay, so some of you do, but I think this is, I'm an architect, maybe I'm biased, but I think the work of the students in this process of designing the thing to be right in the first place, to do, we all know this about sustainability, that you need to start at the beginning. It's a process of integration and collaboration. And we model that in the studio, starting with good design.
I like that you're teaching them production drawings.
Yeah.
I'm a factory guy, so most architects don't understand how to do production drawings. And in factory setting, you got to understand how all that works. You got to have
Absolutely.
the details. That's great.
Some things to kind of point out, if you can see here in the photos, particularly in the entrance room as you come in, you can see it's got the high vaulted ceilings because you've just got panels up at the top. You can see the HVAC tube running through there, which is simple but effective, and really accomplishes those goals. This is another prototype you did. You want to tell briefly about this one?
This project actually was part of the Department of Energy's Solar Decathlon, if anyone is familiar with that. And this is in a very rural place, St. John, Kansas. It's a town that has about 900 people in it. And you can see the solar array in this photo. Due to the size of the house, I think Kansas is a great climate to do passive first, design for load reduction. If you do this right in Kansas, you're going to save the time you're actually going to rely on your HVAC systems is only going to be about 60 or 40% of the year. So to get to net zero, it only takes 12 380 watt modules. So very inexpensive system. This house also has a porch. Some of the basic design ideas are to make this connection to the outside to get people actually going outside. And I think something we're starting to talk about a lot more is user education, getting people to sort of commit to the energy-saving behaviors in the house. I know this is a structures and systems panel, but that's, you really have to do that to make that work, to sort of teach people how to use the house.
All right, Ted, tell us a bit about what you're doing. You've now been doing it for 21 years, evolving from using SIPs to now net zero, net positive homes. What are you doing?
Yeah, well, what really got us to switch over from predominantly stick framing to doing SIPs was a house that we built in Seattle. It happens to be Seattle's first net zero house. It was during the downturn, I think it was 2010, and they had a budget of about $180,000 and wanted to build this net zero energy house with SIPs, and called me up and asked me if I could do it. I said, well, of course, because I didn't have any other work. So, and so we went through and we figured out, okay, what do we need to do this? Okay, we need the solar panels, we need the SIPs, we need the triple pane windows. We had our energy calculations, so we knew what our heat loads were. We knew all these parts, and then we had to go through and figure out, well, what can we get rid of? And one of the things was, complicated design. We came up with, the house was very simple, rectangular box. You realize every piece of surface area has a price to it. And so every little indentation, you look at a plus sign, and you're basically paying for a house that would be a rectangle that would encompass that plus sign. And so we started just building with rectangles, which work really well with SIPs, easy planar designs. And then we're like, well, we have this building material that can handle large spans in different ways. And so we started exploring, well, how do we do that? How do we make our window sizes so they work with SIPs? I mean, value engineered all these details, right? Until we got to the point where we're really at cost parity with typical code minimum construction, with just a few upgrades like the solar and and SIPs cost a little bit more, but what you get out of it, ends up paying back over time in a pretty compelling way.
So we got a video here of a time lapse of a project you worked on. Do you want to tell us how long this time lapse is beforehand, or you'll tell us afterwards?
Well, let's look. You can kind of see the sunrise and set, and so I haven't.
And he's got some great music here that he wanted me to take out because we don't have the rights to it, but I said, who cares about rights? There's no one in here who's caring. We were playing music beforehand. Here we go.
One of our guys had a GoPro that he set in a tree, and so you can kind of see there's two houses side by side as we're framing them up. And obviously, this is the first day, it's still light out. Yeah, we do take breaks, but second day.
Was there a prize at the end for if you get it done quicker?
We did have two teams. One team work on one side, one team work on the other side. And there was definitely some heavy competition. We had a crew of 8 at that point, so I think there were like four.
So 8 total people working on
Yeah.
this, what we're saying.
Wow.
Okay.
Yeah. What, is this the third day?
I think so.
Is it often sunny in Washington?
Yeah, like all summer long. It's like we have a drought every summer now. And yeah, just noticing it'd be neat if you had a stick frame house going along beside it, because framers are fast. It's not a slow part of the project in general, but you don't frame 2 houses this size in 6 days.
Team A's running away with it.
Well, the roof setting, we had one boom truck, so we did.
There you go.
But we did all the roof panels on, both houses in a long day.
That's an infill lot,
Yeah.
so it
infill lot
helped
in
to
North
go
Seattle.
fast.
Yeah.
Yeah.
And what did you say? Is it a wet lot?
An infill lot.
Okay. What is that?
Well, an infill lot it's an existing lot in an existing neighborhood, and I
Yeah.
think we're in a place now where our neighborhoods have tremendous value because they already exist. And if we can, strengthen our neighborhoods by building new construction in them,
Yeah.
that's very important.
It was one of those places where there was a tiny little original farmhouse in the middle of a pretty huge piece of property, and it was a over 100-year-old building that was, full of asbestos and knob and tube wiring and falling down. So we started out that project with demoing the house and then getting the site ready to build those 2 places.
So team of 8,
Yeah.
6 days, start to finish,
6 days, yeah.
getting it to where pretty much airtight.
Yeah. Yeah, ready for roofing and windows.
2 houses, 2 stories.
Yeah.
What was the square footage of each of those, roughly?
I think they were around 3,000 square feet apiece.
Okay.
So bigger houses by our standards. We do try to keep ourselves to smaller houses, but
You're 2 stories, though. You went up.
yeah.
So while it's fresh on your mind, you just saw that, and we'll get the microphone out if it's possible. Good. Any questions from what you just saw on that video that you want to ask Ted about? I've got 2 here on that table.
Just a question for Ted. What are some of the challenges with building like an actual community of these homes? I know that a lot of manufactured builders are building site-built homes for particular lots. I'm just curious about that.
Community, well, the most we've done is 2 next to each other, and I'd say you gain a lot of efficiency. I mean, I'm sure production builders know this, but you gain a huge amount of efficiency by being able to build right next door. I mean, we use the same sets of tools and the same boom truck and the same, just being able to jump from one to another. And even in our practice, we're building 6 houses this year. They're in different areas, but we're able to jump our subcontractors just from one house to the next to the next. So,
Is it just about buying land and the business model primarily hasn't evolved to that type of?
no, we haven't got there yet.
Yeah.
That's our next hope, is to be able to buy land and build some spec projects. We've done exactly one since the downturn, which is a whole different story.
Thank you.
I think there was another question at that same table.
Yeah, I was just wondering, what's the typical weight of one of those 4x8 panels?
The typical, sorry, I missed that.
Typical weight.
Oh, on a 4x8 panel? Generally speaking, they're roughly around 5 pounds per square foot. The wall panels, like you saw in the video here, for the most part, can be manhandled. Sometimes just one person can tilt up a panel. You're not physically like actually lifting it up. You're kind of sliding it up against the bottom plate and tilting it up. So for wall applications, it can be handy to have some sort of mechanical equipment there, heavy header panels, for example. But for the most part, it can be done manually. For roof panels, you definitely need to have some sort of equipment. It can be, I like little cranes the best because the crane parks in one spot and can do the entire roof from that one spot. But some people do them with the zoom booms or the Gradall type, anything with the boom that can reach. They're a little bit more difficult to deal with though because you're constantly having to move the machine into position.
We set our roofs with a 5K telehandler with a boom.
Yeah.
Until we found the Army guys, and now we can set them with Army guys. When you got enough help and
Yeah.
you've got some tall people. I think one of the advantages of doing the SIP roof is actually you get it right up on the roof and start working on it. You don't need to, you should be tied off and everything and be safe, but you don't need to walk all over an open frame. I think there's a huge safety factor in building like that because you don't have guys walking around on the tops of walls.
We minimize the time spent on the roof quite a
Yeah.
bit. Usually it's just me and one other guy for one day to do the entire roof. So that just the amount of time up there is a lot less.
Is there one more question out there? Or text, maybe two?
Here's a couple more.
Good.
I don't know if it's helpful, but we usually have 3 to 4 people on site for framing walls and then a full crew of like 6 or 7 for doing roofs. Because sometimes you do need to manhandle those individual panels or person handle, and having 6 people, you spread the weight. I mean, the biggest panels are what, 600 pounds?
Yeah, the biggest panel, they can come up to 8 feet wide and 24 feet long without any additional lumber material around any plate material in them, just the panels themselves. They're closer to 4 pounds a square foot. So, 192 square feet times 4 pounds, you're almost 800 pounds. So lifting a jumbo panel, obviously you'd need several people. And if you're doing roof panels, to have some kind of equipment to help, definitely.
Yeah, if you have to handle them by person, if you have 6 people, then you're only like 150 pounds apiece. And so
That's right.
it's reasonable
you
to
can
move
do
them
it.
around.
Okay, question out here.
Can they be manufactured for taller ceiling heights?
Manufactured for, sorry?
Tall ceiling heights.
Well, yeah, that's exactly what they are manufactured for. Typically, SIP roof systems are, the panels are put on top of exposed glulam beams or timber rafters. So you've got, they're meant for vaulted ceilings. You're actually eliminating the trusses. Is that what you?
No, it's actually referencing like in a 2-story structure on the first floor.
You can have any wall height you want. I mean, you can do a panel sideways and you end up with an 8-foot wall.
Yeah.
Or you can stand them up to get a 9-foot or 10-foot or 24-foot high wall.
And so are you asking on, well, we saw the 2 stories, the floor for the second story, was that a SIP? Is that what you're asking?
Right.
Yeah. And what?
I'm
So
okay.
can you ultimately get a 9-foot first floor ceiling?
Yeah, absolutely.
Yeah.
Like the panels, generally, as I mentioned earlier, they start out at 8 by 24 feet, and we cut the individual pieces out of those panels. So if you have a 10-foot ceiling, for example, a typical wall panel would be 4 feet wide by 10 feet high. You can actually sometimes even balloon frame. So if you do have a 2-story building, you potentially, there's some engineering that has to be looked at, but in theory, you can balloon frame all the way up with a single panel up to 24 feet high.
Other questions out there? One here at this table, and then we're going to move on.
My question's more of a remodel question. I know we were talking about new build right now. My understanding of a SIPS house is everything comes prefab, so you have your raceways built in for anything like that, right, for electrical. How hard are those to move, and can you cut panels in the field? Is that suggested, or should you have new ones made? So my question is, let's say, for example, you want to put an electric door lock in. that wasn't there before. You had a standard Baldwin lock, just everybody uses it, and then now you want an IoT system to open up your door when you have your hands full. How hard is that raceway to build in, or does it have to be put on top, under the cladding outside? How does that work?
Do you want to answer that one?
Sure, yeah, the electric door locks that I've put in just go in the same holes that the regular door locks go in.
Yeah, I would say, it's actually
There's wiring involved that you have to run to that doorway now.
Yeah.
Oh, gotcha.
The panels that are there will typically have some sort of grid pattern of horizontal and electrical chases built into the panels. So if you can use an existing chase to pull your wire through that, typically they're completely unobstructed. So, if you can use an existing chase, then it's actually quite easy. In some ways, it's easier to do than a stick frame house, because with a stick frame house, you'd have to at least cut out the drywall. And even if you were just feeding it through along with the same wires, here you don't have to cut out the drywall. If you can find a place to start, you can pull right through. If it's like low voltage and it can't be, it has to be sort of separated from the higher voltage, that might be a little trickier. There are ways to do it, but that might be a little bit more.
I think it's something from kind of a design and engineering perspective. When we did our first house,
Good segue.
we furred out our walls because we were using SIPs that had studs in them. And actually, going into that house, the electrician that did that, and actually the HVAC sub as well, were commercial people, and they knew exactly what to do. They sort of put everything together, like in the middle of the house. They used the kind of ceiling, kind of frame down spaces for everything. And actually the systems on the outside of the house were really, really minimized. And that just, made me think of how, everyone always wants to know, well, what about the wiring in the exterior walls? And it's like, you might, there's like one cable that kind of zips around, and then the kitchen is a little different, but I don't think it's that big of a deal. It's something that can be designed.
Well, and that's the thing, with panels, this type of prefabrication, the importance of the design and engineering. And in this case, the design, it really does have to be thought out before, or during the design phase of the project. And ideally, you want to keep as much of the electrical out of the exterior walls as possible anyways. I mean, even
You already do it with plumbing.
Yeah,
Not a good place to put your systems.
Right, you typically, you're not gonna have any plumbing in an exterior wall. And even in a typical conventionally framed, stick frame building, if you really pay attention and look around, there's only a certain portion of the electrical on the exterior walls. So with prefabrication and SIPs in particular, if you can get it all out of the walls and keep the electrical to interior partition walls, all the better. Keep it down to a minimum, because you're just inviting air leakage and things that you have to go back and deal with later. So the less, the better.
If you do need to go back later, you guys, I know, give us a plan that shows exactly where those electrical chases are. And so we get, building a new house, we get to tinker with that and say, okay, we want one 9 inches from either side of every exterior door, and we want one here, and we want one there. And but if you were an owner of an existing SIPS house that was built, within the last 10 years or so, you'd probably be able to go back to those original panel drawings and see exactly where those chases are. I know we give each homeowner a homeowner's manual with a complete set of plans on a thumb drive. So any of our houses, if you were going to go in and remodel, would have that information, so they'd know where all the chases were, so you could hit one pretty easily.
So as a preface to talking more about the design and engineering that needs to take up front, I wanted to ask Josh to tell us a little bit more about the size of the Habitat home and the cost of the home and kind of the time to build and what they experienced there.
Yeah, so in our local market, the price for labor is abnormally high, and that's driven by a number of factors, including the cost of housing. And so one of the challenges that we were seeing was the cost per square foot of finished construction. And this high cost per square foot of finished construction was driving the development of larger and fewer larger properties. And so we put on the table that we would like to develop a structure that is no larger than 1,200 square foot at a rate below $125 per square foot. And so we're seeing in our local market, we're seeing development costs ranging from $180 all the way up to $500 a square foot for finish in some cases, more the high-end finish cases. And so we were able to deliver that lower cost per square foot through design because we're using space more efficiently, and that's largely due to the design that the Kansas State University team put forward. But also we're choosing our finishes. We're not using cheap finishes at all. We're using custom cabinetry, and we're using locally manufactured countertops. So we're using the type of high-end finish that our market is accustomed to in the home buying space, but we're delivering it with a much smaller footprint and at a much lower cost per square foot. And some of those cost savings are realized by the reduction in professional labor that's needed to assemble the project on site. And that's largely due to the use of prefabricated panels. And those panels allow us to bring large sections of walls and roof units to the site and assemble them very quickly. And we were using student groups for the assembly. So our work sites are also classrooms for architecture students and construction science students. And even with the slower pace of an educational environment and the less experience used by that students have, we were able to be weather tight in 3 days on the site, which in Kansas, the weather can be somewhat variable. So being able to identify a short section of good weather for site assembly and then getting out there and getting it done is really, really helpful, really important in the professional space as well, because it reduces the amount of mobilization necessary on the site. And so as we look forward to our current project, we've been able to further reduce that site construction time by actually extending the prefabrication to include the exterior continuous insulation and the zip panels on the exterior, so that once the panels go up, they get taped and they're completely sealed for the site and ready for siding, and they get glazed. Our current build gets glazed on site, but it could have been glazed in a shop environment, which would further reduce the time on site to build. All the builders who have come to the site, the builders and the developers who we've brought to the site, they're usually a little surprised when we tell them what our cost per square foot to assemble and our time to assemble is. And I think when they hear those numbers, they assume that we're doing that by performing at a lower quality. But when they come to site, what they see is that we are actually performing at a higher quality standard than what is typical in our building environment. We are doing it at a lower cost per square foot, and we're doing it faster. So through design, we are doing better, faster, cheaper. And that is something that developers are really scratching their heads trying to figure out how they can onboard into their delivery systems.
So Michael, tell us a bit about the behind the scenes to make that happen.
Well, I think so I teach architecture students, and I teach them about how to practice in a future world where sustainability is of growing importance. I think Prefab is a lot like sustainability because it's an integration problem, and you have to kind of start at the beginning with the idea. You can't just sprinkle prefab magic on a project that you already have. So it takes a team of people that kind of knows what's going on, and no one is really sort of an expert in a bubble. Everyone kind of knows what everyone else is doing, and I think that's actually that idea translates into the field with the construction technology students and our collaborators too. So this is a daylight analysis for our houses. We use a lot of technology you would normally just use in a commercial building, but no one ever thinks to use it in a house. As an aggregate, our homes in the US actually use more energy than commercial buildings. So when you drive around, you see all those office parks lit up at nighttime with lights on in empty offices. It's like actually houses are using more energy, which is insane to me. Also, the average American household emits about twice as much carbon dioxide emissions from their utility consumption than they do from driving. So everyone's really self-conscious about their cars, but our homes are really the problem. So designing for daylight, we have the tools to do that. So we do that in a very simple way. The windows in our houses are usually around $300 to $3,500 for the window and door package. Very inexpensive when you design to performance target and really understand what you're doing and use the right tools. So we use passive first principles to reduce load, good shading of the house, using some of that winter sun is beneficial, allowing for natural ventilation. Most climates in the U.S. have enough available good climate and air movement. It doesn't take a lot of windows to do that. So our houses are not huge glass boxes. And daylight can reduce a lot of your electricity load by keeping the lights off in the daytime, but it can also help with cooling. So a lot of heat gain in a house comes from lights and also equipment. And if you bring that down, you're allowing that house to cool better. And we also use a fully insulated slab that helps as kind of a thermal flywheel effect. So it kind of tempers the fluctuations in temperature in the climate. When you put all that stuff together, you get a house that works really well, but it's also a healthier house. There's a lot of evidence we see in school and commercial buildings that daylight, connection to the outside, all those really good design principles, they help people. They enhance health. And I think Ted had mentioned that there's a lot of important stuff in the details. So part of our prefab system is that we can use things like exterior insulation. We can reduce a lot of thermal bridging. I joke that in practice, if you sit down with a contractor for the first time and you say continuous insulation, it's like a cartoon. You just see like a puff of smoke and then they're gone. So we can use continuous insulation. It's really not a big deal. We keep our roof designs very simple as well. That helps make a good solid roof. But we've worked that out, and it's actually there's a lot of flexibility in these systems too. I think that's also a misunderstanding with prefab, that if you prefab a building, it has to be a box or it has to be a certain shape. I think it's more efficient to have a certain shape, but that can also be flexed. But I see what we do as not just the having a value in sort of the shop and the production side of things, but also all of this stuff has to come from somewhere, and the design and the planning part is really important. We actually make these drawings, and a lot of times the drawing set, by the time you get to the end of the project, it's really clean. It's not all like ratted, like bent up and torn up and doesn't have drawings all over it, because like it only goes together one way, and people can see it going together. So that's a kind of another funny little anecdote.
Mm-hmm. Ted, anything you'd add to that?
Yeah, I love the idea of keeping projects simple. It makes it easier for everybody to build. And if you've built a number of houses, every single house has a couple of like really tricky, weird spots, and just iterating over years and figuring out how do we eliminate those tricky, weird spots and have designs that are super buildable. And then repeat some of those designs. So
what's a value proposition too? So I think there's like the HGTV effect, where what consumers want is they want a really complicated house from the curb, and then they want it to be kind of the same inside. And I think the value proposition of designing the thing better is that the the inside of the house is more functional. It's more focused on how people actually use the house. And simple can actually be more desirable if you do things that people really want, which they want space and they want functionality.
Daylighting. I mean,
Yeah.
it's huge. Like having a well daylit house. I mean, we try to put the same paint color on the inside of every house for that reason. Just a bright, white, neutral paint color, because then the light bounces around. It doesn't get stuck there. And so you can with combination of where you put your windows, what the visible light transmittance is on all your windows, and those are numbers a lot of window manufacturers will let you play with. You say, I want a 0.5 visible light transmittance, and you'll find the glass layup that works for that, and usually it doesn't cost anything extra. Kind of with the cardinal glass and stuff that we're using, we can specify all that, the solar heat gain and the visible light transmittance.
Right. Okay. So moving on to give Jason a chance to talk. He's been kind of quiet so far. We're going to talk a little bit about what Vantum can do, that if you want to make it an easier transition, how you can enable companies to make this easier, particularly looking at the volumetric, starting to do the six-sided box that you've been talking about.
Yeah, great comments from everybody, so there wasn't really much to add. Really good stuff. It's all about designing for manufacturing. Our product's net zero ready, so we just don't know how to build any other way. It's part of our DNA. It's about air infiltration. It's about using the right windows. These guys are all talking the absolute right stuff. We just do it at a scale. We do it in a factory. This is how people right now are building factories trying to optimize an inefficient system or automate an inefficient system. I won't call out names, but there's plenty of factories that are building out of wood timber, right? And this is what they're investing in. And these are very capital intensive to put together, and to be honest, tons of moving parts, lots of parts and pieces, a thousand ways to screw it up, and you'll do it 2,000 ways. And, so this is just an example of automating inefficiency. You get the wood build, and you're going to insulate the wall. Even though it's an automated insulator, you still have another part piece. Now you're H-flocking your insulation in there. Now here's an example of optimizing efficiency. This is how we make our Vantum panel. Very automated. There's two guys that run this line. So this is, if you've never seen a SIP factory or how they make SIP, this is one example. This is the way we do it. It's very fast. We have a couple of different types of glues we utilize, hard and cold. So our panel press is about a 1 minute long panel press, and that panel is ready to go to the CNC to start cutting. It is a very low carbon solution. Our average 2,000 square foot home compared to a builder next to us, we have an 85% lower embedded carbon footprint in that envelope. So it'll set in that press for about a minute, and then it moves on. From there, we take it into automation, and then we turn it into boxes. So we actually take it beyond the wall panel solution on site. We've done over 3 million square feet of this type of construction in South America. We've built the Straits of Magellan Whale Observatory. We're the only one with a house in the South Pole. The Atacama Desert hasn't rained there in 300 years, 120 degrees heat. So we perform better in hot and cold environments, right? This is about energy envelopes. This is a particular volumetric piece going out in South America right now. We completely finished that unit. It is complete on the exterior. We use a super lev material. It has a cork inside that material, so it has a 10% retention memory. We don't crack, so we won't have cracks in the joints because of that 10% retention memory. I'm working with Bear and 3M right now in Minneapolis on creating that solution here, so I don't have to buy it from outside the United States. So we have some great science groups in the U.S. to create some of this stuff. But it all starts with the envelope. This is a pod of a 5-star hotel that we did in Uruguay, and you can see everything inside of that is finished. And notice the glass. Notice how much glass we have on that end cap. Typical wood construction, you don't do that. It won't engineer. The structure's not there. Our panels are very strong. They are structural panels. We can go 3 stories without anything added to our structural envelope. We go above that, then we have to start adding some structural support.
And
But
so give an example of what type of furnishings you're putting. I mean, obviously we
they're-
can see a bed and a couch in there, but it goes even beyond that.
Well, yeah, I mean, they're 90% complete. The appliances, the carpeting, the flooring, the ceramic tiles, the shower door enclosures. When we're doing Marriott hotels or any other branded hotel, when you open the bedroom door, it's done. Everything is complete. There is nothing to do except in the corridors. So we take, the biggest fight we're going to have is trades and skilled trades. We bring them all inside of a factory. It's a teaching environment, and we do all the work there, and we deliver it out complete like that. It's just stitching that's done on site and some of the exterior cladding.
And we spent some time yesterday talking about resiliency, and there was a question this morning of, well, we don't want to use this because we're in Florida.
Yeah.
We've got some before and after pictures here of one of these houses
Right.
that was before hurricane and after hurricane.
Yeah. Our chairman of the board actually had a house in Freeport, Bahamas when Hurricane Dorian went. And if you see there to the left, that is the before and after picture. All this client had to do when that water receded is pull their electrical wiring out of the walls that are in the cores, new breaker panel, base cabinets, and flooring. Our product doesn't mold, so there's no biologicals. We don't have to remediate for water.
How high was the water in this?
All the way to the almost very top of those windows for 2 weeks before the water went out.
Wow.
The houses to the right, the top, that's in Chile. Santiago, we went through an 8.2 magnitude earthquake in Chile. It was the largest recorded. No issues. Again, we have retention memory in our joints, so that's a nice product. And then the Atacama Desert over there to the right, that house has been there for a long time, and it never rains, 300 years. The one on the very bottom is the home we did in the South Pole. It's still there. So if you don't know, in other parts of the world, when you build a product, you actually have to build a home and let it set for 3 years, and they get to inspect it over a 3-year period before you get a license to build there. So we've been doing this about 8 years. We received investment from Breakthrough Energy Ventures, which is a fund put together by Bill and Melinda Gates to attack the carbon use in the world, and we're their only housing solution they invested in. We'll be putting 15 factories in the U.S. with builder-developer partners. That's our goal, is to reduce that carbon footprint in housing. We could have a whole other seminar on just what housing and construction does to our carbon footprint. We look at materials that will actually eat carbon and pull it, and we can use it in our home that'll pull the carbon dioxide out of the air into our envelope and actually reduce that as well. It's pretty technical, but there's some really neat stuff out there.
On the top right, fire resistance. Talk a little bit about that.
Yeah, we'll in SIPs, you have to, or any construction, you have to meet fire ratings, and so this is a test being done by NTA that is burning the wall, and our wall is. A lot of people ask me, is it MgO? Is it magnesium oxide? Is it an MgO board? It's not. It has a portion of that in there, but our group bought Burrell in Houston for the simple reason we needed coal ash for the next 200 years. It lowered our carbon footprint even further in our envelope by using a coal ash, which is a byproduct waste of coal. So we have coal ash in there. There's a lot of materials in what we make and how we make that. We didn't patent it because patents expire, and we just simply took the Coke method. So you can't get that ingredient. A lot of people try. We've had 9 years of practice at it, and it's ready to go. We are certified here in the United States with NTA right now. But it does have a refractory material. I use the analogy with people because I'm a visual guy, but when you imagine the space shuttle coming back in the U.S., everything on that thing is white except the nose. The nose has a black refractory material on it, which is what we use in our walls. And that's why that shuttle doesn't burn up into many pieces when it comes back in the atmosphere. You can burn and burn. The only thing that ever gives on that test is the actual EPS behind it. Our wall will not fail. It's the heat of the foam that will eventually disintegrate.
So as we're on the home stretch, I want to go around the panel here of any other advice that you would give to this audience, to builders who are interested in going whole hog in. We'll start off with Josh and his thoughts.
For builders, I would say that you are experts on how to deliver safe and durable housing units that represent the largest investment that individuals make in their entire life. You are handling a level of trust that is really seldom placed in individuals' hands. by incorporating new technology and leaning into performance, you are not creating additional risk, but you are creating additional value for your home buyers. And by leaning on nonprofit organizations and educational institutions to really pilot new technologies and to test new technologies, you can rest assured that these technologies are safe and they are durable, and they're something that you can put your brand on.
For the rest of you, what are some other advice you'd give for this audience?
Well, I think integration is important to realize the real value of prefabrication. So you can't, you have to have the design part of it. You have to be able to take that product in the field and make it happen. I think one of the things holding back prefab is that there's a lot of builders that actually, it's forced on them by owners the owners want the prefab, but the builders don't want it. So they kind of penalize. There's a cost penalty there. It gets marked up like anything else in the house, but it gets marked up a lot. So I think actually what you're doing, Ted's great. So like you have, you're integrating the design and the building and the field crews, and it's all kind of happening at once. I think that's a great model.
And we did that because we started off with architect design houses that, they would maybe design one SIPS house, or the engineer would engineer one SIPS house. And so we had all these projects that just had piles of lumber in them. They just weren't efficiently designed for a panelized product. And so we realized pretty quickly, like, engineering's the key, like having an engineer that knows SIPs and understands it and how to make it efficient. And then design is part of that key, making sure that you're not asking the SIPs to do things that it doesn't want to. Sure, you can do anything with enough shear walls and nails and beams and things like that, but how do we make it lean and cost effective? And it's a material that performs well in certain circumstances, so how can we let it kind of guide our designs? And so that's where we started designing our own places to make them that much more efficient to put together. That many less parts. If you can cut the number of parts in half, you double your, how fast you can build the place. So
there's some schools and universities all using this technology. We've done 111 schools in South America. Those are all charter schools in the top left. They're all net zero, net positive when we add the solar. And then a university at the bottom. I'll say this to the builders. Look, I didn't create this statement, but I read it. We didn't leave the Stone Age because you ran out of stone. We left because of innovation and technology. And I would give Autodesk all the credit for my industry and where it's moved in BIM and 3D. It started with Autodesk and Revit. When architects and teachers start teaching the new way of construction in the architectural level, it works its way to the builders and developers. It really started there. I use another phrase that's in our presentation. Optimizing inefficiency just optimizes the inefficiency, or automating inefficiency just automates more inefficiency, like I showed in that clip of wood, timber, being all these parts and pieces to make a wall. We've got 3 pieces to make a wall: structurally sound, energy efficient, and it's now time to kind of start to change the way you're thinking about how you build. When 2030 energy codes come, you're going to have a harder time to meet that energy code when this type of solution already gets you there from the start. It allows you to really be above the rest. You'll get left behind. It will happen.
Well, I made a tactical error today. We were supposed to finish at 12:45. I thought we were scheduled for 1, so we went a little bit long. You all have one-on-one meetings that start in 2 minutes, so we're going to go ahead and wrap up right now and take a quick bio break. Thanks for being here. Please join me in a round of applause for our panel today.
Thank you, everyone.
Thanks.